Hello friends, welcome to Stuff Networks. In today's video, we are gonna talk about OSPF v2. Its full form is Open Shortest Path First version 2. So without wasting any time, let's begin our video. OSPF v2 Open Shortest Path First version 2 is a link state interior gateway protocol designed for IPv4 networks to find the shortest path to a destination. It ensures fast convergence, efficiency and scalability in enterprise networks by allowing routers to exchange link state advertisements and build an identical topological database. OSPF v2 versus other protocols. Unlike older protocols like RIP that uses hop count, OSPF v2 is more efficient and faster at converging, updating routing tables when change occurs in the network topology. Let's talk about how OSPF v2 works step by step. First, neighbor discovery. Routers first find each other using hello packets sent every few seconds. Use multicast address 224.0.0.5. If settings match, they become neighbors. Second is adjacency formation. Not all neighbors become fully connected, only required ones form adjacency. Exchange detailed information, prepare to share routing data. Link state advertisement exchange. Routers share information about their network using LSA. Contains link, costs, and topology information flooded to all routers in the area. This creates a complete network map. Fourth is built link state database. Each router stores all LSAs in a database. All routers in same area is equal to same LSDB. This is the brain of OSPF. Fifth is shortest path calculation. Routers run the shortest path first algorithm, which is known as Dijkstra algorithm, finds best path to each other based on the cost bandwidth. Now, our sixth one is routing table creation. Finally, routers install best routes into the routing table used for actually packet forwarding. Let's talk about difference between OSPF v2 and OSPF v3. OSPF v2 is used for IPv4 networks and OSPF v3 is designed for IPv6 networks. OSPF v2 uses network-based configuration, but OSPF v3 uses interface-based configuration which is more flexible. OSPF v2 includes IP addresses inside the packet. OSPF v3 separates addresses and relies on IPv6. For security, OSPF v2 uses basic authentication like MD5, but OSPF v3 uses IPsec, making it more secure. OSPF v2 uses IPv4 multicast addresses, but OSPF v3 uses IPv6 multicast addresses. OSPF v2 supports a single instance per process. OSPF v3 supports multicast instances per link. Both require a router ID even in OSPF v3. So in short, if we understand it, OSPF v2 is for IPv4, but OSPF v3 is for IPv6 with better security and modern features. This is an multi-area network topology diagram. Let's talk about this diagram. To handle routing efficiently and on time, this protocol divides an autonomous system into areas. Area is a collection of routers, hosts, networks, all contained within an autonomous system. An autonomous system can be divided into many different areas, but at the same time, all networks inside an area must be connected. The figure we can see below, we can see that the network is divided and can be structured or subdivided into routing areas to simplify administration and optimize traffic and resources utilization. Routers within an area flood the area with routing information. At the borders of these areas are special routers called area border routers. These routers summarize the routing information within their respective areas and send it to other routers. Among the different areas, there is a special area called the backbone area. to which all other areas are connected. It serves as the primary area in the network. Each area has a unique identification. Two different areas cannot be directly connected. They must be connected through the backbone area. There is a mandatory requirement. Routers that connect two areas such as Area 1 and Area 3 do so through an area border router. Now we will configure OSPF in Cisco Packet Tracer. To configure OSPF, first we have to put three routers here like this and three switches downside of these routers like this. And now we will place three PCs down here. 1, 2 and 3. Now, before configuring their IPs, I will add some modules in this router. First, we will turn it off and I will use WIC IT module. We will turn it off and after work done here, router 1 we will also add like this. In router 1 we will add two modules like this, and router 2 also we will add one module like this. After adding modules, now I will connect all of them with wire. Now we will give all of them IPs. Now we will configure IPs in all of the devices. First we will configure IP of the PC1. So we will click on PC1 and go to desktop, and here we will write IP192.168.1.2. We will give gateway IP of our router dot 1.3. Same we will give IP here, desktop IP here. The IP is 192.168.2.2. Here we will give 192.168.2.3. Same we will do in PC3. 168.3.2. Now we will configure IP of our router 0. We will go to CLI. Here we will write no, enable, configure terminal. Here we will write interface FA00. Now we will give IP address 192.168.1.2, sorry, 1.3. Now we will give subnet mask 255.255.255.0, and we will write no shutdown to make the interface up. Now we will give IP of SE0/0/0. Sorry, by mistake I have written FA. We will write SE0/. Here we will give IP 192.168.4.2. We will give subnet mask 255.255.255.0 and also write no shutdown. Okay, we have configured successfully our IP of router 0. Now we will write exit and again exit. Done. Now we will configure IP of router 1. CLI no, enable, configure terminal, interface. We will write interface FA00 and the IP is 192.168.2.3 and we will give subnet mask 255.255.255.0. We will press enter. Now we will give two IPs here of SE. So first we will write no shutdown. So to give two IPs, first I will give IP of FE00, FE010, sorry, SE. The IP of SE interface 010 192.168.5.2. 5.2. Now we will give subnet mask. You can see this IP 192.5.2. Now we will give subnet mask 255.255.255.0. Then write no shutdown. Now we will give IP of interface SE0/0/0. Now we will write no shutdown and exit. We have configured IP of router 1. Now exit, exit, done. Now we will configure IP of router 2. We will go to CLI. Sorry, first I will turn it on. Now we will go to CLI. Let it complete. Then we will start configuring. Write no, enable, configure terminal. Oh, sorry, I have written spelling of terminal wrong. Now we will give IP to interface FA00, interface FA00. The IP is 192.168.3.3. You can see here 3.3. Subnet mask 255.255.255.0. Done. Now we will give IP to interface SE. Sorry, SE0/0/0. Done. Now we will write IP address 192.168.5.3. 255.255.255.0 is our subnet mask. Now we will press enter and write no shutdown, and we will exit. Again exit. Done. We have configured IPs of all the routers and PCs. So you can see all the interface is up now. So now we will start our process of configuring OSPF. So to configure OSPF, first we will create areas, area 1, area 0 and area 2. So let me, first I will choose color. Black. Oh sorry, I didn't press OK. Now let me remove this. Now we will make areas. This is our area 1. Done. And this is our area 2. And this is our area 0. Sorry, I will make it again. Area 0. Okay, now it's better. So we will also write names here. First let me settle it like this. Okay, done. Now I will give them name. This is area 1, area, this is our area 2, and this is area 0. Now we will configure OSPF in all of these routers. So to configure OSPF in them, we will click on router 0, and in CLI I will press first enter, and here I will route enable, configure terminal, and I will write here OSPF, sorry not OSPF, I will write here router OSPF 1. OSPF 1 is our router's ID. So now we will configure OSPF. I will write network. Our router 0 is connected with PC 0. So here I will give PC 0 network 1.0, and here we will give wildcard mask 0.0.0.255, and this router is in area 1. So I will write here area 1. Now we will give network of SE0/0/0. I will write here 4.
and I will press enter. Done. Now we have finally and successfully configured OSPF in router 0. I will write exit, again exit, and done. Now we will configure OSPF in router 2. So we will follow same steps. Enable, configure terminal, and the OSPF ID I will give here to router OSPF2. We will press enter.
Here we will write the network of our PC.
192.168.3.0 because IP of our PC is 3.2, so we will write 3.0, and wildcard mask also we will write here, and this router is in area 2, so we will write here area 2, and now we will press enter. Now we will give right here 5 and press enter. So done, we have finally configured OSPF in router 2 also. In our area 1 and area 2, OSPF is finally and successfully configured. So now we will configure OSPF in area 0. So here I will press router and write enable, configure terminal, we will write network of our PC 0 here, which is 192.168.2.0. Wildcard mask also we will write, and area 0, and we will press enter, and now we will give area 1 network, and here we will change area 0 to area 1. Now press enter, and we will also give right here 5, and this is our area 2, and now we'll press enter and exit, exit, again exit. So we have finally configured OSPF in our all areas, area 1, 2 and 0. We have configured OSPF. In area 1 there is OSPF 1 and OSPF2 in area 2 and OSPF3 in area 0. The network command in OSPF is used to enable the OSPF protocol on specific interfaces, define which network are advertised, and assign those interfaces to a specific OSPF area. It acts as a filter, allowing OSPF to run only on interfaces whose IP address fall within the defined range and wildcard mask. Now we will check our OSPF configuration by running some commands in CLI. So first we will write enable, and our first command is show IP protocols. We will write here show IP protocols. Basically, this command confirms OSPF process ID networks in area. Example, networks matching area 012 and router ID looks for your configured networks under correct area. Now, our second command is show IP OSPF. So we will write here show IP OSPF. This command display process details area supported. Example, area 0, area 1, router ID and area border router status if applicable. Now we will run our more commands in our area 0 means router 1. So we will click on router 1 and go to CLI and run our first command. Our first command is show IP OSPF interface brief. Interface brief. This commands lists interface running OSPF, their area, process ID, neighbor count and state. Ensure interfaces connect to correct areas. Area 0 for backbone links. Our next command is show IP OSPF interface. This command gives more details on timers, cost, and network type per interface. Our next command is show IP OSPF neighbor. This command shows neighbor, their states, full DR or full BDR, areas and routers IDs. Neighbors should be full on matching areas. Mismatches indicate config errors. Next command is show IP OSPF database. It checks LSA types. Example type 1 router LSAs intra-area. Type 3 summary LSA inter-area from ABRs. ABRs routers in area 0 plus another areas should propagate routers. Now we will send packet from one PC to another PC to check if OSPF is configured properly or not. You can see I have sent one packet and here successfully came. So this means that our OSPF has configured properly and successfully. You can see again and again successfully is coming down here. So that means our OSPF is configured properly. Thanks for watching. If you found this video helpful, don't forget to like, share and subscribe, and also press the bell icon for future updates.